In this problem, we have a vector that's in 26-dimensional space, and it's making equal angles to all of the axes that it's in. So we're going to take this down to a 2-dimensional space so we can figure out what the problem is asking and notice some very interesting things. So let's draw a vector that's going to make an equal angle to both of the axes. We got one right here on the right. This is going to make angle theta. And of course, we have another one here that's going to make the same angle theta. But in this case, we're dealing with the x-axis. So let's focus on trying to figure out what the x-axis tells us about this angle. And so in order to figure out what the x component is doing, we'll use cosine. This is x, this is going to be y, and this will be, this is just going to be r, because r is going to be equal to the square root of x squared plus y squared, right? And so anyway, we're going to have cosine of theta is going to be equal to x divided by whatever we have there, so x squared plus y squared. And then let's take a look at the other angle. This is going to be theta on this side. We're going to notice something interesting. This one here also makes this being the x-axis and this being the y. Then we could say, okay, let's figure out what the component in the y direction is, and that component is going to be cosine of theta is going to equal y over the square root of x squared plus y squared. It's cosine because, again, it's the adjacent side. Okay, and let's say if we were going to the other dimensions, first of all, we notice that if this is the case, these two must equal themselves. So x must equal y, because otherwise this would be impossible, right? Great. So that if we wanted to go into other dimensions, we would probably figure out the same type of thing. We'll use the adjacent side in order to get the component in that dimension, giving us the z component over the hypotenuse x squared plus y squared plus z squared at this point. So yeah, so we know that x equals y, which equals z, and we can even push this into the nth dimension and go as far as we want, you know, because now we could say that cosine of theta is equal to n divided by the square root of, think of this as just a whole bunch of n squares, n squared plus n squared plus n squared, all the way 26 times, so we're going to have 26 times n squared. Okay, and then this is just going to sort of cancel out because you'll have n divided by n square root of 26, and then you'll have that the cosine of theta is equal to 1 divided by however many dimensions that we stuck in there. And so, of course, theta is going to be equal to the arc cosine of 1 divided by the square root of however many dimensions. And that's going to be a general formula to figure out what's the angle that's in between this vector for any dimension. It's pretty interesting.